Okay, so question 8. An arithmetic progression is such that its first term is 6 and its 10th term is 19.5. Find the sum of first 100 terms of this arithmetic progression. Okay, so important thing is that this is an arithmetic progression. First 100 terms sum is what we need to find, and first term is 6, so that means a1 is 6. 10th term is 19.5, so that means a10, that is a plus 9d is equals to 19.5. How do we get a plus 9d? We know the nth term formula to be an is equals to a1 plus n minus 1 times d. So whatever will be n, here will be n minus 1. So if we have a10 here, so a1 plus 10 minus 1 would be a1 plus 9d. So this is how we always generalize that whenever we have nth term, here will be n minus 1. Okay, so a plus 9d is 19.5, so we get this one expression out of it. Okay, so when we know a1, so can we find out d from this expression? a1 is 6, so 6 plus 9 times d is 19.5. So 9d is 19.5 minus 6. What is it? It is 13.5 over 9. So d will be you will be having, after calculating this, d will be equals to 1.5. Yeah. Okay, so this is how we found a and d. Now what is the next thing that we need to do? This is an extra thing, so let's take it aside. Then we have done this whole calculation, so we can just adjust it over here. And now we need to find the sum of 100 terms. So s of 100, that is what we need to find. So what is the formula for sum of n? Sum of n is n over 2, 2a plus n minus 1 times d. So s of 100 would be 100 over 2. What is a? A is 6. So 2 times 6 plus 100 minus 1 times 1.5, that is your d. So 50. 6 2 times is 12 plus 99 times 1.5. Okay, after calculating this, what we will get? 8025. Okay, or you can check this calculation. The process is correct. Okay, that's it. Now let's move on to part B. Now comes the tricky part. Normally we have very simple questions for this arithmetic and geometric progression, but here is a special case where they are giving you a little variation in these type of questions. So let's read this out. A geometric progression. So the main thing is that we have now a geometric progression, so a different set of formulas are going to be used for geometric progression. a1, a2 and a3 is such that a1 is 24 and the common ratio is 1 over 2. So what have they given you? a1 and r. The sum to infinity to this geometric progression is denoted by s, and the sum to infinity of a even numbered terms is denoted by se. Find the values of S and SE. Okay, so let's start with sum to infinity of this progression, what they have given you, for which they have given you A1 and R as well. Okay, what's the formula for sum to infinity for a geometric progression? This formula is very simple. A over or A1 over 1 minus R. What is A? A is given to be 24. And what is 1 minus, what is R? 1 over 2. So this is it. Solving this out, you will be getting it to be 48. Okay, 1 minus 1 by 2 will be 1 by 2. 2 will go in the numerator, multiplied by 24 will give you 48. Okay, so that's it. Till here, it's the simple version of it. Now they are talking about a different progression that is composed of even numbered terms for the previous given progression. So the thing is, let's first write down that progression. Okay, the progression is, we had the first term to be 24. Okay, then what is your common ratio? 1 over 2. So the next term would be, after multiplying by 1 over 2, it would be 12. The next term after multiplying by 1 over 2 would be, this is your geometric progression first that is given, is going to be 6. The next term would be 3. And so on. Secondly, now they are talking about the even number terms. This one was A1, this one was A2, this is A3, and this is A4. Now they say that even number terms make an other geometric progression and find the sum to infinity for that progression. So now what will be your geometric progression for even number terms? It will be 12, 3, and so on. So you may write a few more terms as well if you want. So it will be 3 over 2, then it would be 3 over 4. So you can write that too, but this much is also enough. 2 terms are enough to identify any to like solve any progression. Okay, so 12 and 3. So let's do sum to infinity is A1 over 1 minus R. So A is 12 here. First write the first term for it and the R for it. So A1 is 12 and R will be 3 over 12, 1 over 4. So sum to infinity will be 12 over 1 minus 1 over 4. So 12 over 1 minus 1 over 4 would be 3 over 4 and 4 over 3. So 4 times will be 16. So after calculating, sum to infinity for even would be this. Okay, so let's differentiate this. Okay, just keep it this way. So this is now going to be your new even term geometric progression, and this will be the sum to infinity for it. Okay, these are just the common ratios that we used. I'm just minimizing it so that we don't think of them as the terms just as a combination multiplier. So this is your question 8. Okay, this is all what it is, and this is how you can solve it easily if you understand this statement. Everything else comes into place. Okay, now